Hello dear students, welcome to a new chemistry session in chapter 4 entitled Chemical Reactions. At the end of this video, you'll be able to identify the type of a chemical reaction. You need in this session a pen and your chemistry booklet. Consider the following changes in the given reactants. According to the nature of the changes that the reactants can undergo, generally 4 types of chemical reactions may be distinguished. What are these 4 types of chemical reactions? The first type is called decomposition reaction. During decomposition reaction, one reactant decomposes into its constituents, which could be elements or other simpler compounds. This can be represented as AX gives A plus X. For example, MgCO3 decomposes into MgO and CO2. The second type is called combination or synthesis reaction. During combination reaction, reactants combine to form a single compound. This can be represented as A plus X gives AX. For example, Cu plus S gives Cus. The third type is called simple displacement reaction. During simple displacement reaction, an element in a compound is substituted by another element. This can be represented as A plus Bx gives Ax plus B. For example, 2NaBr plus I2 gives 2NaI plus Br2. The fourth type is called double displacement reaction. During double displacement reaction, an element in a compound displaces the most chemically similar element in the other compound, forming two different compounds. This can be represented as Ax plus By gives Ay plus Bx. For example, HCl plus NaOH gives NaCl plus H2O. Combustion reaction. Combustion reaction can be considered as a fifth type of chemical reactions. It occurs in the presence of oxygen gas. The complete combustion of a hydrocarbon produces carbon dioxide, water vapor, and heat. For example, butane gas C4H10 burns in the presence of oxygen gas in the atmosphere to produce carbon dioxide, water vapor, and heat. The chemical equation is C4H10 plus O2 gives CO2 plus H2O plus heat. To balance the number of carbon atoms, multiply CO2 by 4. To balance the number of hydrogen atoms, multiply H2O by 5. To balance the number of oxygen atoms, multiply O2 by 13 over 2. To get rid of the fraction, you should multiply the whole equation by 2. 2C4H10 plus 13O2 gives 8CO2 plus 10H2O plus heat. Therefore, generally there are 4 types of chemical reactions: decomposition reaction, combination or synthesis reaction, simple displacement reaction, and double displacement reaction. Let's do an application together. Balance the following chemical equations and give the type of each. The first equation is Al2O3 gives Al plus O2. In the reactants we have 2 aluminum atoms and 3 oxygen atoms. In the products we have 1 aluminum atom and 2 oxygen atoms. To balance the number of oxygen atoms, multiply Al2O3 by 2 and O2 by 3. To balance the number of aluminum atoms, multiply Al by 4. This reaction is a decomposition reaction. The second equation is FeS plus HCl gives FeCl2 plus H2S. In the reactants we have one iron atom, one sulfur atom, one hydrogen atom, and one chlorine atom. In the products we have one iron atom, one sulfur atom, two hydrogen atoms, and two chlorine atoms. To make the equation balanced, we should multiply HCl by 2. The type of this chemical reaction is double displacement reaction. The third equation is H2 plus Cl2 gives HCl. In the reactants we have two hydrogen atoms and two chlorine atoms. In the products we have one hydrogen atom and one chlorine atom. To make this equation balanced, we should multiply HCl by 2. The type of this reaction is combination or synthesis reaction. The fourth equation is NaI plus Br2 gives NaBr plus I2. In the reactants we have one Na atom, one I atom, and two Br atoms. In the products we have one Na atom, two I atoms, and one Br atom. To balance the number of I atoms, multiply NaI by 2. To balance the number of Na atoms and Br atoms, multiply NaBr by 2. Thus the equation becomes balanced. The type of this reaction is simple displacement reaction. The fifth equation is C3H8 plus O2 gives CO2 plus H2O plus heat. In the reactants we have 3 carbon atoms, 8 hydrogen atoms, and 2 oxygen atoms. In the products we have 1 carbon atom, 2 hydrogen atoms, and 3 oxygen atoms. To balance the number of carbon atoms, multiply CO2 by 3. To balance the number of hydrogen atoms, multiply H2O by 4. To balance the number of oxygen atoms, multiply O2 by 5. The type of this reaction is combustion reaction. Dear students, you have to carry out this assignment. You have to solve the applications in worksheets 14 and 15. Thanks for listening.